Hey student, welcome back. So in the last video, we talked about what is the definition of the derivative and where does it come from. And in this video, we're just going to be working a few problems that you might see in the beginning of this unit. So let's get started. We have the limit as h goes to 0 of x plus h all squared plus 3x plus h minus 9 minus just the function again. Now, important here to put the parentheses because we're subtracting, we're going to have to change the sign of every term. So x squared plus 3x minus 9 all over h. Okay. And you can see once the exponents get much larger, this definition gets kind of hard to use. So we actually do have a tool that makes this much faster that you'll learn in like a week. But for now, we need to know how we use the definition. So we'll continue. H goes to 0, x squared plus 2xh plus h squared plus 3x plus 3h minus 9 minus x squared minus 3x plus 9 all over h. And here we cancel everything we can. We've got an x squared and a negative x squared, a negative 9 and a plus 9. We've got a plus 3x and a minus 3x. And everything else has h in it. 2xh, h squared plus 3h. I'll go ahead and write that again. So the limit as h goes to 0, 2xh plus h squared plus 3h all over h. And you'll find that this h cancellation step is really important because we need to get h out of the denominator. So we need to be able to cancel it with every term in the numerator. So if we've just got a 3x left up here, like if we didn't cancel it in the last step, make sure to check your work and see that you can get rid of that. Okay, so finally, the limit as h goes to 0, 2x plus h plus 3. We can just plug in h now. And this limit would be 2x plus 3. This derivative would be 2x plus 3. And for notation's sake, that would be equal to f prime of x. So moving on to the next one. We have y equals x to the fourth minus x squared at x equals 3. So if you get a problem like this at x equals 3, that means we're going to use the second definition. So that means we're going to say the limit as x goes to 3 of f of x, x to the fourth minus x squared minus f of a, 3 to the fourth. Let's go ahead and write that. 3 to the fourth minus 3 squared all over x minus 3. 3 to the fourth, 3 squared, 9 squared is 81. So let's say 81. And 3 squared is 9. 81 minus 9, 72. Okay, we're not calculators. We don't need to do that all day. So moving on with the actual math. We have x to the fourth minus x squared minus 72 all over x minus 3. Once again, if we plug in 3, we're going to get 0 over 0. So we need to do some simplification. In a situation like this, factoring is the best thing for us because we could get rid of this x minus 3 in the denominator. Factoring is hard though because we have an x to the fourth minus x squared minus 72. If this is something that's very hard for you to factor, it might help if you think of x squared as a secondary term. Let's call it b. X squared is equal to b. So, and we'll go back and replace the x, but for now, let's say we have b squared because x squared is b, so x to the fourth would be b squared minus b minus 72 all over. I'm not going to change the x minus 3 for now. Let's keep this the same. X 3. Okay. B squared minus b minus 72. If we factor this, it ends up being b minus 9 times b plus 8. Limit as x goes to 3 over x minus 3. Okay. Now, let's get rid of our b. We don't need that anymore. We can go back to blue. The limit as x goes to 3 of x squared minus 9, x squared plus 8, all over x minus 3. Okay, so now we can keep factoring in the numerator because we still can't cancel. That x squared minus 9, we can use the difference of squares method of factoring. So this will become x plus 3 times x minus 3. X squared plus 8, we can just leave alone over x minus 3. Okay, now we can cancel and then just substitute. But first, let's write x to 3, x plus 3, x squared plus 8. Now we can just substitute because we're not going to have any issues in the denominator. 3 plus 3, 6 times 3 squared, 9 plus 8 is 17. 6 times 17. Don't really know right now off the top of my head, but this is our answer. That would be our slope at this point, whatever that is, 6 times 17. I'm not going to get my calculator out. All right, we're moving on to the next one. We have g of x as the square root of 6x minus 2. So let's get started. We plug into our formula, the limit as h goes to 0 of, this one's going to be a little harder to write, but 6x plus h minus 2 minus the square root of 6x minus 2 all over h. Okay, now this is why we did a lot of work with these kind of strange limits in Unit 1, because what do we do here? We're not going to factor. There's not a lot of good canceling we can do. We need to multiply by the conjugate. So 6x plus h minus 2 plus the square root of 6x minus 2 all over that. 6x plus h. And okay, now let's see what happens when we multiply. So multiplying by the conjugate takes advantage of the difference of squares factoring rule. So this will just become 6x plus h minus 2 minus 6x minus 2. Now I'm going to put that in parentheses because that negative will become positive. And then in the denominator, I'm not going to multiply this through yet. We're just going to leave it as is. 6x plus h minus 2 plus 6x minus 2. Okay, so now we can do some work in the numerator. We have the limit as h goes to 0 of 6x plus 6h minus 2 minus 6x plus 2 all over this monstrosity. 6, we don't want to do this. We don't want to write all this, but we have to. 6x minus 2. Okay, and now we can start canceling. 6x, negative 6x, those go away. Negative 2 plus 2, that cancels. And now we have h on top, and we're multiplying by h in the denominator, so those will be able to cancel, which means we will be able to find our limit. Okay, so let's see that. The limit as h goes to 0 of 6 over the square root of 6x plus h minus 2 all in the square root plus 6x minus 2. Okay, now we can just plug in h is 0. So we have 6 over 6x minus 2 plus the square root of 6x minus 2. We have 2 of those. So we can, if we want to simplify, we'd say 6 over 2 times the square root of 6x minus 2. We can simplify further. We could say 3 over all of that. Or we could even bring this up and say 6x minus 2 to the negative 1/2. Square root is to the 1/2 power. So since it's in the denominator, we can bring it up and say to the negative 1/2 power. Okay, and now our final example for today. Let's do purple. We have y equals 1 over x minus 3. And I'd be remiss, we should say, what was this function we were looking at, the last one? G of x. So this would be g prime of x. That would be how we label the derivative, g prime of x. So our last example, we have y equals 1 over x minus 3. We say the limit as h goes to 0, 1 over x plus h minus 3 minus 1 over x minus 3 all over h. And this looks, a little bit complicated, but we did deal with similar limits in Unit 1. And our strategy for dealing with these is to get a least common denominator in the numerator. So x minus 3, and we'll multiply by x plus h minus 3, which I know looks difficult, but it's going to work out. It's going to help us answer this. So the limit as h goes to 0, we'd have x minus 3 over x plus h minus 3 times x minus 3. And that denominator will be the same for the second fraction, so we don't need to write it again. Minus x plus h minus 3 all over h. Okay, now let's cancel what we can. So the limit as h goes to 0, we have x minus x. Well, let's go ahead and write this out. So x minus 3 minus x minus h plus 3 all over x plus h minus 3, x minus 3. And I'm actually going to bring that divided by h up. So it's times 1 divided by h, just to save some space. Okay, canceling, cancel, cancel, cancel. We have negative h over all of this times 1 over h. So those h's will cancel. And we'll be left with the limit as h goes to 0 of negative 1 over x plus h minus 3 over x times x minus 3. And we've got rid of our h's, so now we can just plug in h equals 0. We get negative 1 over x minus 3, or negative 1 over x minus 3 squared, or negative x minus 3 to the negative 2. Okay, and this was y, so y prime equals this. We actually have another notation we can use as well, but we'll talk about that in a later video. Thanks for watching, and keep watching. We'll see you in the next video.